Yeah.
Okay. Thanks.
Can we get a whole bunch of goodies?
Sure.
9 to be exact.
That was a good exact number. 2. Will the mini hands up the driver?
I think they do.
There you go. Enjoy the park.
Thank you.
You're welcome.
Life is like a hurricane in Duckton. This cause is everything. It's a Duckton. It's all the mystery. Or rewrite history. Duckton.
Hey, Daddy-o.
Oh no. Dismount. Okay.
I'm here. I'm here. It's okay.
Okay.
No thanks, we don't want any. Come on in!
Hi.
Welcome to our humble abode.
Oh, how cute. Okay, tell her your names.
I'm Eric.
Eric.
Steven.
Okay.
Here we have a refrigerator.
Is it fully stocked?
Oh, this is called, like, Garden of Eden. Look at yogurt fruit juice. What more could you want? And diet vanilla caffeine-free Coke.
Wow.
Caffeine-free, man. Now turn around. It's the beautiful feature here.
Tiny dishwasher.
Dishwasher. Cute. I'm making me another burger. Long drive.
What's up, ladies?
Yeah.
Not bad, huh?
Well, maybe I'm sorry.
Hi.
Kind of thing. So were you guys on your way here?
What's up? Hello, Sheena.
Hello. Yeah, he was just gonna
Yeah, we're doing some real camping here while we're watching TV.
That's why we left a little early. Yeah.
Hi, we're just here eating lunch, sitting outside enjoying the outdoors. We've seen a lot of wildlife, and then we'll get to our little ecology project with our park rangers that came with us.
If you get a chance, you should definitely check it out.
This is Eric eating lunch.
I was here a few summers ago, and that's when I had a day here, but that was one of the places we stopped at. It was a geology thing, so we were like...
Like them?
How you doing?
Good.
I'm
They
doing
did.
fine.
They had access to Beery Farms, and so they died.
What are we eating here?
They stuck it in like a Cafe Rio tin thing.
Brian,
They
what'd you
stuck
make?
it in their oven at like 3 o'clock in the morning. Turned the oven on warm, so they woke up their whole apartment.
1 second there.
The
I had a
best
sandwich, peanut butter and jelly,
ever.
raspberry jelly, it's really good. Had some
I
banana
wasn't
berry
involved. I just enjoyed the aftermath.
yogurt. I have a granola bar here, I have another granola bar in there, and an apple.
You're a big man.
Amen.
Because we're going to be so noisy. So the procedure basically, we'll just go out here, and then I've got some rebar here, and we'll permanently mark the plot so that we can find it again. If this site burns, we'll want to come back and remeasure the fuels, and that'll give us an idea of fuel reduction. And it's good to mark your plots like this anyway. If we're going to all the trouble to collect this data, we may want to come back to it someday. So we'll start by just installing some rebar, and then getting a GPS fix on that, and we'll show you how to use the GPS. And then we'll break up into 4 groups, and each of my folks will lead one part of the procedure. What am I forgetting, Becky? There's lots of important stuff. You want to label all your data sheets. That's been an issue too.
Fill out every line on top.
Before you start collecting data, be sure you fill out the header, your name, date, and site where we're at the very least, so that we can sort of figure out what happened later on if we need to. So labeling is very important. Same with the bags. Be sure to label your bags, what it is, what you're collecting, and the site and the date. What else?
Compass is this, and it always points north. You have a needle on there, it's magnetic, so it always points towards magnetic north. And what we're going to be doing is we want to make a wedge shape, and we need to be consistent with it. So we're going to measure out 5 degrees. So anyway, what you do is you got this dial here turns, but the needle always points north. And if you look, there's a inner arrow, and you want to line that up so that the north arrow is sitting on the arrow that turns on the inside there. And what that does is it gives you a degree bearing that you're pointed at. So just to set it up, that tree, that dead tree standing single by itself, black bark, is sitting at 68 degrees right now from us. So that just gives you your bearing, your mark. So
Cimarron. Wait, no.
Cimarron's going to
Cimarron,
Anne.
are you running to Anne or Julie? Okay.
Oh.
hey Eric, give me one more point. I need one more. We have 5 tapes, right?
The brown string set? Yeah, there's one.
Yeah,
There's
one
another
for each.
tape.
Alright, if you guys get lower, I want to see... You said act natural.
The vegetation is quite thick. It's hard to walk through.
Alright. We'll be on some lower trees here.
I want to go up there.
Hey Cimarron, you want to run out there and just be up to your neck in trees so I can
And
get a
build
good...
a little fort out of these things and live amongst the trees.
Hey wait, stay where you guys are. You're coming in too fast.
We want to get in. Freaking time.
I just went and collected some pine needles. We're going to take a moisture count of how wet the vegetation is out here. This here's just some pine needles. Had to fill it up. We had to tape it shut so no moisture escapes before we get home.
Did you get them off the ground or off the tree?
Off the tree. These are living pine needles. Not anymore though. They will be dead.
Today, what I had to do was identify 10-hour, 100-hour, and 1,000-hour dry logs, and that just tells how much, according to the diameters, how long they will be burning. And so these are the tools that I used. Right here is a calibrator, so we only use these on a 1,000-hour log. So look right over here, and we'll test out this 1,000-hour log. And it turns out we're doing it in centimeters. Happens to be 19.3. So what we would do is we recorded them all on here, and we had all these transects, 4 different sections, and we went through, and we're not done with it at all, but we went through and we had to label all of them 10 meters apiece. And then we used this to make sure we went 10 meters. So we'd take out our compass and like pick a random spot and then just pick a point and take this out 10 meters, and from there we'd identify all the 10s, 100-hour, and 1,000 hours and record it on the sheet.
What does 10, 100, and 1,000 hours mean?
Okay, let me show you. 1,000 hours, the one that we just measured out. This would probably be a 10-hour.
All right.
Then this would be 100-hour. So it's just saying that's how long it would burn if this forest were to go up in flames.
Okay, for our little thing, we counted the number of trees in like a 4-meter diameter spot. So we just go out on the lines that were set up, and we go to different like spots, and we just take our tape and measure it out to 4 meters, and then we made an X so we could have a circle. So we had 4 quadrants, and then we just go in those and count the number of trees and the number of seedlings. And the trees that were above 1.4 meters, we would measure the DVH and the height, record that. That's about all we did.
Thank you.
Alright, hello. Today we went out and measured how deep the litter on the ground was, where the fuels, how high they were, to know if it would reach high enough to reach like the trees and canopy and stuff like that. So what we'd do is we'd go out to these stretches of tape, and we'd go to like 30 meters out, or 35 meters out on each of the 5 sections of tape. And when we got out to the point where we wanted to measure, we'd pull out the tape measure how high each piece of litter is. So right here you have like pine needles, just some sticks, and then below that you have some duff, which is like the thicker black type of material. Not quite minerals, but it's more, has actual vegetation in it. That's duff. So we'd measure how deep that was. And then also each sticks, like this stick right here, log you have, would be about 8 centimeters. And this log here, it's about 25 centimeters. And we just kind of get an average and say overall it was about 18 centimeters. That's how high the vegetation or the litter was. So and then we just write that down on each board at each segment of tape. That's about all we did.
Hello, people. We took these, made a little square at certain locations on the plot. So you got the square. We set them down. We collected all of the litter and that's more litter, and the 1 hours. And then we placed some bags, and we're going to take them back.
Will you show me an example of some litter and 1 hours?
1 hour?
Okay, hold on. Let me see. Okay.
Small little twiggy thing. And litter would be like pine cones and pine needles.
Simulations that we're actually back at the Gibbon site that we did 2 days ago on Monday, because that's the data that we have. We actually crunched some of those numbers this morning. So we got to pretend we're back at that Gibbon site. You'll remember the one that was really thick, and you guys probably have nightmares about it. So basically, we're going to pretend we have a fire start, and then we're all going to be fire monitors, and we just got helicoptered in here, and we got dropped off, and we're going to do some fire monitoring. And we're going to gather some weather information. We're going to use the flip through our photo series find the site that, or the picture that best matches our site, which of course is going to be that given site, and then use our laptop to figure out what we can expect for fire behavior. So the first thing we want to do is measure the weather right now, and so it's what, like 12:30 or something?
12:45.
12:45. So each firefighter has a weather kit. Weather is so important, just about every firefighter has one. And inside the weather kit there's a bunch of stuff. Sling psychrometer here. This measures your RH. It's got a dry bulb and a wet bulb. And I'll explain that in a minute. They also have anemometers. I don't have one in mine. After a while you can just get an idea of, they call it the Beaufort wind scale. And basically, if you can feel it on your face, that's about 3 or 4 miles an hour. If dust is raised on the road, it's about 6. And if your saplings and things are blowing around in the breeze, then you're in the 8 to 10 range. Let's see. So, psychrometer. Was there a question? Or? Basically, it's got a dry bulb and a wet bulb, and you want to wet the wet bulb. It's got this wick on it. Get that good and wet. And what it's going to do is, when you sling it around, it starts to evaporate that moisture off the wick. So it takes about a minute or so to spin it around. The dry bulb doesn't have any moisture on it, so it's just not going to change. But that wet bulb has that wick on it. It's got the moisture. The moisture is evaporating, so that bulb's getting colder. From the difference between the two thermometers, you go to a scale, and you can factor in elevation, and you can figure out your dew point and your relative humidity. So I'm just going to sling this here for a minute, and then you want to periodically check it. So the dry bulb right now says 72, the wet bulb says 66, so it's already gone down a few degrees. So I'll just keep spinning it here until that wet bulb levels out. And actually, while I'm doing that, there's other ways you can do it. They come out with new gizmos like this Kestrel weather collector, and it does just about everything. It's got that little fan in there, so that's measuring wind. So I just face into the wind. That's showing 2.2 miles an hour right now. 2.4. So it's just kind of a real moderate wind. To our tables. And first thing you do is find your elevation, which here, we're above 7,000 feet, so I'm going to go to the table at between 6,000 and 8,500 feet. And it's got a dry bulb on this side and wet bulb on this side. So we'll go down to dry bulb with 71. It's on the next page. And then our wet bulb was 57. So that's going to give me an RH of 49%. That seems high. This morning, it might have been 50 or 60%. By the late afternoon, in August or September, the lowest I've seen it in Yellowstone is like 8 or 9%. But you get down in 12, 15%, you'll start seeing torching. And then below that weather reading, there's tables back here. You can actually predict your fine dead fuel moisture from that relative humidity, because basically they're 1 hour fuels, so they're going to be tied right to RH. They're going to be lagging an hour behind RH. So you can predict the moisture in your 1 hour fuels, and the litter, and this dead grass here. Basically anything that's going to be about a 1 hour fuel. These are keyed into time of day. So our time of day. So this information we would relay back to the fire cache for use in fire spread models. And okay, so the top is all fuels information, and this is data that we've collected from our given site. So basically, it's just going to give you rate of spread and flame length, and it'll do some other things too. Like if you can estimate how long your burn period is going to be, it can tell you, the fire is going to burn this far in the direction of the wind. It's going to burn this far, flanking against the wind, and it'll give you acreage and things like that. But this program has actually been around probably since the 1970s or so, before computers were even really a big thing. and they used to have them just pieces of paper called nomograms, and you would had 4 graphs basically with all this information that we've collected here, and you would start at one graph, you know, at your 1 hour fuel load, and basically draw a line over your 10-hour fuel load, drive a line over your 100-hour fuel load, and basically you just draw these crazy lines all over this nomogram, and eventually you would wind up at a rate of spread in the flame length. Basically the computer just does that for us now. Rate of spread is 1.4 chains per hour, and a chain is 66 feet. It's a forestry term, so it's about 20 meters. So 1.4, 1.5, it's going to go, you know, maybe 30 meters an hour. So it's kind of a moderate rate of spread. And our flame length is going to be 1.3 feet. So our average flame height is going to be about this high. And just to put that into perspective, basically 4 feet is about the highest flame length that you want to attack with hand tools, with a hand crew. And beyond that, the fire intensity is so high that you need to bring in aircraft or, you know, equipment, engines, that sort of thing.
Huele.
It's one snowy day at the Diamond Bardee. Here's the boys' cabin, and we have our van. Here's the main lodge where we eat all our meals. And here's the girls' cabin. What are you doing?
I'm packing.
Why are you packing?
I gotta go home.
Why?
I gotta go find my family.
It's only Friday.
She's gonna play with her family in Mammoth. We're gonna miss her.
We're gonna be on vacation.
Terribly. Well, we have Sheena. Sick little Sheena. What's wrong, Sheena? Tell us your symptoms.
Nothing's really wrong. I just don't want to go out in the snow.
You know Dr. Barker's going to see this. And what are you two doing?
Getting ready for cold weather.
Why? Is it snowing out there?
Yes, it is. In June.
In June. I know. It is June. Here's our heater. Keeps us warm and toasty at night.
Okay, we stopped at this site right here in the black-tailed deer plateau. Wanted to get a little closer look at it, do some field reconnaissance, see how this compares to the site over by Slough Creek and Junction Butte, Lamar Valley area. What we found, if you want to pan out, is that it is covered in huckleberry ridge tuff. It's a rock outcrop with Douglas fir and a little bit of limber pine mixed in, mixed age. And the trees seem to be associated with the outcrop in general, but it's not as clear of a pattern as what we see over on the other side where there's a boulder and a rock next to it. Some trees are right next to the rock, some of them aren't. They seem to be getting something from the rock outcrop here, but it's a little bit different pattern. So what we decided was that we would consider this to be a separate project and focus on the boulders and rocks more exclusively.
Okay, I'm testing the soil moisture and the pH of the soil. So we have this cool little gadget here that we have to clear away all the dust, stick in the soil. And most of them have been about 7.
He just graduated.
Somewhere on the east side of 7.
Thank you.
And then the soil moisture, you just push the little button and it will show the percent. Usually it's about 50 or 40.
Okay, we're recording the lat long of all of the tree rock pairs and just all the other features in this valley to map them. We're doing it using a GPS. We made sure to get the correct elevation since that's going to play a big part in what we're doing. And with this, what we're doing is recording all the different features in this unit. So they're taking the measurements and giving them to Cimarron for the hard copy, and then myself for the e-copy. And we need to make sure that our PDOP, which is the geometry of the satellites, is a low number. Right now it's at 2.3. So anything below 3 is good.
I'm taking the slope aspect of the tree rock. First, I'll stand on the rock and then tell which side of the rock the aspect's on. And right now I just measured this slope aspect right here. And what I do is I just line it up to north, like this. And it's 42 degrees pH on the north. And it's like, if you can see right here, it says 42 degrees.
What I do is I stick this, I'm measuring the depth of the soil around the rock. I do, this here's the east side, but I also do the south, north, and west. And what we do is we just stick this probe down, and then we just put our finger where it stops, and pull it out. And we measure from the distance where the finger is to the end of the pole. So we'll have Julie come in here and do that real fast.
Julie, the lovely assistant.
Julie, my lovely assistant, isn't she kind? We got about 32. So that's all we do.
32 for east.
That's correct.
We are taking the DBH of the tree, it's the diameter. And we pull this little tape thing around, and we line it up right over here where you can't see very well. And we figure out how wide the diameter of this tree is, if that makes any sense. And then we yell out the number.
What's the number?
Right now, it is 107.2. I don't say it too loud because it changed from last time.
I am just being the data recorder right now, so everyone's shouting out the different numbers, and I will just record everything, put comments on rows of vegetation down here. We've got the rock sizes, the lichen cover, this is soil depth, soil moisture north of Boulder, soil pH northwest, southeast. We've got, like, this is tree 9A, our species, Douglas fir, the diameter, slope, pitch, aspect, and then the tree rock aspect right there.
I'm using this clinometer to measure the pitch of the slope that the rock and tree are on. I can look in this eye hole and see what degree of slope the ground here is.
I really like the rock.
Okay, we're at the Junction Butte South Plot. I have just made a GPS boundary area for this whole Kettle Lake. We're going to use it for our mapping purposes. I'm using this fancy GPS here, and it's strapped onto my head.
Are you taping me now?
Yeah.
You want to scratch that and record some thoughts?
No.
Well, the one thing I was just thinking about was that there was a fire that came through here and killed some trees, and just thinking that maybe the boulders might be offering some protection from the fires. But there is this one right here. This tree was at least apparently killed by the fire, as were many of these, and the boulder didn't seem to offer any protection. So scratch that theory, but all kinds of ideas. We're moving along on this slope, extend out that direction. These ones are very interesting because they're more all by themselves, not on too much of a slope, and some clusters of trees over here as well, so interesting stuff. Okay, the other thing I wanted to mention was about the fires. We just talked about all the little trees that have been killed. However, this was probably the 1988 fire. Had a good 15 years for these trees to start regenerating, and there aren't any seedlings. They're ample cone crops, but no seedlings, no saplings. So
no reproduction.
No reproduction in this area right now. Anything interesting?
Looks like a landslide.
Kettle Lake?
Or
Yeah,
top.
the top to the left, and then over there.
Okay, probably lava is my guess. Okay, what else? Because this is a butte. The lava flows out here. Look away from the lava though, a little bit lower on the butte. What do you notice?
Dead trees.
What do you see that we haven't seen anywhere else?
Bushes.
Bushes. And potentially what?
Aspen. There's aspen
A
there.
little bit aspen.
Different kinds of trees that aren't Douglas fir.
If they're okay, they could be, but they also could be Douglas fir. So we might have some Douglas fir seedlings up there.
Seedlings.
I think some of that's probably juniper, what it looks like to me, but I think over here especially, as Crystal dramatically pans around, I think we may have some Douglas fir seedlings up there. Maybe. I don't know. Maybe. So, I mean, you don't see any fire scars, any charcoal over here, and they're seedlings, so the fire probably didn't make it over. Yeah, well, that's pretty old though. That's definitely not this fire. And that's probably a fire scar, but it's not the same one that happened over here. So, different side over here. We may have some invasion of the lower tree line.
What is this study area called?
This is Junction Butte, and we're calling this one Junction Butte N, or north, because it's north of the road.
Okay, this is our study area out here. You can see them studying. This happens to be the end of the rock tree pair. And if we look out here, we have a kettle lake, which provides a lot of moisture, and so we don't see any of those. But then beyond the kettle lake, we can find a few more rock tree pairs. Not as many though.
One other little bit of point of interest here is that these are a bunch of those small trees that were killed by the fire that came through here. And several of them are growing adjacent to rocks. Some of them are not, but most of them are. Sort of a general boulder field here. There's also very different ground vegetation in there. Some different shrubs that we don't see anywhere else. You just see in this nice little patch around the boulders. So there's something different about this little microsite here. The other thing I noticed is that most of the boulders in there have very little lichen on them, which is a lot different from these big ones that we're looking at with the trees. Could be due to the fact that they're out in the sun more, or they could just have been exposed more recently than the bigger ones. More stuff to chew on.
It's going down soon.
Yeah, it is. It's right there.
I just don't understand.
Alright, we're done. Let's go hiking.
Chopping down, like chopping down these trees for the pure joy of it. I know.
We already went to the center.
That's it. Jump on the tree sitting.
I thought we were coring trees today, not cutting them down.
Some of the dead ones.
Does Yellowstone know we're doing this?
It's so close. That's when we go to the other back it, you know? Then we go, no, I'm talking. That hurt.
Right there going at it? Yes.
Just a little.
Bye-bye, tree. Oh. There he goes.
Whoa!
Some big seedlings like right there. There's a few.
Yeah, we kind of destroyed the center right there.
Stand and pose on these
Here's
turkeys.
our crown tree right now. We're doing it to see what the age of this 400-meter plot is. I've already got it through the tree, so I'm going to use this little thread right here. Stick it in. Okay, and I hit the core. I'm going to turn once back this way, and I'm going to start pulling it out. Should I shove it all the way in?
Mostly. You don't have to crank it in at the end, but. Oh, let's see this.
And here it is.
Back up.
Okay, push stop. Okay, we're coring trees right now to try to determine the age of the forest. We set up a little 400 square meter plot. I've already put this in to the tree. Now I'm just going to take out the core by sticking these threads in. That. Until I hit the core, and I'm going to go back
A little more, but you're pretty close.
Should come out if everything goes right.
Ooh.
I don't think it's coming.
I got a bullseye. Woohoo!
Did it not go?
More like 1,000 trees.
Stop it! Okay, I think that we have this at this time. Oh no, I don't
Sauce?
think so.
Sauce.
Okay.
You come here. You come here.
Just turn it very slightly. Right. Don't do cram it anymore. Just turn it slightly. Not that much, not that much. Just a little bit.
Ooh, is this it?
Let go, let go. And this is our core. It's not a very big tree. I give up, Matt.
Okay. So I turned off.
Okay, stop. Okay, we're trying this one more time, and I think we just might have it. Yep, here it is. We're going to put it into our straw that I've already taped up. Saucy. There we go. Fill it out. Feed it into our straw.
This is the bullseye pin.
This is screwed up again.
Here. And let's just look. I barely grazed the core right there. The tree.
Gemini cord?
Gute stove. Oder hungry?
Fifth from the geyser, take one.
A little bit of activity.
A little bit of jail for a while. Where are these?
You could be in the geyser basin.
What time is your watch say?
Yeah.
We got a little bit.
And then I fall asleep and it go out.
There we go.
Wow.
We're here with Rebecca Rebecca Rowland, and she works here at the park, right? Okay, and we're just going to get her to tell us a little bit about the geyser and why the plumbing is so crazy.
Why it's so crazy?
Yeah, what's going on?
We're on top of the volcano.
An active volcano.
An active volcano.
Okay.
With a crater that's 40 by 50 miles wide.
So why isn't there lava coming out then? Why is that steam and water?
Steam and water because the lava source is still underneath the earth 3 miles to 8 miles down.
Oh, okay.
And it heats up the groundwater. It heats up the groundwater down there first, which is brine, salty from contact with the rocks. It starts convection cells, which heats up the rest of the groundwater above it. In the shallow depths, like on Facebook.
I got my badge.
Causes pressure to build up. You
Okay.
got your badge. This is Morgan. She's a
Hi,
junior
Morgan.
ranger in
Let's
Yellowstone.
Say hi to the camera. Hi.
Hey, Morgan.
Well, thank you for your time, Rebecca. Welcome. Bye.
Oh, that sounds good. You're good, man. You're fine. Oh, you missed it.
Oh yeah, I missed it. It's not Old Faithful.
No, it's done.
Okay, behind us is the Elixir Crater Geyser, or Geyser Crater. It had extremely violent eruptions in the late 1880s. There were eyewitness accounts as late as 1888. They believe that its eruptions were actually so violent it broke its own plumbing. The reports say that the plumes were as high as 50 to 300 feet in the air. And since then it's been dormant. However, in 1985, for 47 hours, it was erupting again. So they don't prefer to call this extinct, they just call it dormant. And it's extremely unpredictable, so it could go off today for all we know.
The mud pots things. And the reason why they're mud pots instead of hot springs is there's not enough water coming up from the ground to shoot and make a hot spring. So it just heats the ground dirt and makes it a mud pot.
I want to look at my natural meteorology, but I'm not a mathematician. Physics is okay, like we've got A's, physics classes, but
Can you see a rainbow?
Yeah, I'd like to get the rainbow.
trail. And down here you get an excellent view of the lower falls. However, there were only 326 steps that we could statistically find out about. But the view is absolutely beautiful of the falls, and there's rainbows and snow and rock slides and it's beautiful colors.
Look at the pretty mountains over there too. She's the tallest one of her. Am I gonna get in trouble with my shirt?
Alright, I'm gonna go over here.
Okay, this is the Black Dragon's Cauldron. It smells really bad out here. There's sulfuric acid, a little sulfur in there, and microorganisms do something with it and make sulfuric acid, and it really stinks.
What's it smell like?
It smells like rotten eggs. You ever seen like Wilbur and Charlotte's Web? Kind of like that. Oh, terrible. Oh man.
Hello, this is the Mud Geyser. It's on the same loop as the Black Dragon Cauldron, and in this spot, if you look over here, you can see the dragon's cave, and you can hear his breath as he roars and smokes from his cave. This is another hot spring. This one is called the Dragon's Mouth Cave. Again, you can see the steam coming out of the dragon's breath, and you can hear his roaring noise.
This mountain up here, there was an earthquake in 1959 which caused a massive landslide which covered all of this once forest area down to the river, up the slope, and onto this side of the highway. It was covered with mud and all these kinds of dirt and stuff. Fortunately, certain groups, I don't know who, but they were able to create a dam for the lake up there and create a new river and push the sides up so it would be safe again. This is the boulder that was dedicated as a memorial to the 28 people who were killed in the landslide in 1959, right here.
Okay, we're explaining the earthquake lake landslide, Medicine Slide. The big boulders, did you film those? Memorial boulders are dolomite, which is a sandstone, tilted about like that, and a whole bunch of weathered metamorphic rock behind that. The earthquake caused that sandstone to break off, and all that weathered metamorphic rock came flying down behind it, and the rocks were pushed up on the other side.
Glacial geology suggested that might be a lateral moraine, and it looks kind of like it. The problem is that the lobe is not running down the valley, it's running down out off of Sepulchre Mountain. So it's a landslide, and a very young one. That lobe came down out of that swale up there where you see the aspen trees. And it came down after the flood, so it's younger younger than 14,000 years for sure. Much younger. Now, why is there so much landslide material? Remember when we were talking about the rocks and then the absence of the rocks, and then here they come again? And someone said, well, that's a landslide. And whoever said that was exactly right. That when this huge glacial mass of ice was cranking down this valley, it steepened the walls of the valley. If you ever go to Yosemite, you got sheer valley walls and a flat valley floor. Geologists call it a U-shaped valley. It's a dead giveaway for glaciation. So you've got these real steep valleys composed of very weak rock with the ice holding the walls up. You get rid of the ice, right, they slump. And from Sepulchre all the way down to the Yellowstone River are compound slumps. You look at a geologic map of that section of Sepulchre and it's landslide, 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 landslide.
My daddy's stuck again?
No, we got him out. He was stuck.
So did my mom. My mom thought it was a good parking space and got stuck.
How'd she get out?
Bed. I bet the construction workers have bed it before. Sorry, Paula. Sorry, honey, we don't got enough food for you.
It's a grizzly bear, right? Yeah, has a big old hump on its back. I'll hold off like this.
Again.
I always like to show you their backside.
I noticed. It's a bare butt.
What I saw was a grizzly bear.
Maybe they're playing, I bet they're playing tag. That's all it is.
Oh, here it comes.
About 15.
That one looks like
Not particularly agile.
They're just gonna ride in the road with us.
This happens every day on this road.
I know.
That's great.
We're out here in the wilderness and we just spotted a moose.
big.
It's a big one.
We've been roughing it this trip. But thank goodness we did because we saw this moose here.
She just kissed the moose. Look at that. She got some action. They're up on what?
Oh, watch out! He's gonna gore you with them. This is a very mature moose.
Is it a boy?
Now, if there were more than one moose, we'd call it minks. So there he is, and so we just say moose.
my ice cream scooping?
Yeah,
Hey, that looks great.
How's that? That looking good?
Tell them to make it bigger.
So do we get 15% discount?
Sure.
Oh, that's pretty. Look at that.
That camera is awfully persuasive.
Ice cream.
I know.
This is amazing. What flavor are you getting,
I'm
Brian?
getting maple nut on bottom and tuner sundae on top of a sugar cone.
Okay.
Y'all.
And what was your name again?
Andy.
Andy. Oh.
That's my middle
You're
name.
in Yellowstone Park and you're filming the guy scooping your ice cream.
We're physically gonna film the moose too.
This is a Yellowstone. Okay, there we go.
Can't be all rehearsed like that.
Can I have a taste of the Just Peachy? Yellowstone Just Peachy. You need to have Yellowstone names, like this should be a geyser.
Like Old Faithful.
Andy, turn around. Say hi to the camera.
Hi.
Andy?
I didn't see moose tracks.
Okay, I'll have one scoop of the Just Peachy.
In a cone?
In a cone, please.
Moose tracks.
All right, signing up. It's an awesome place. I hope it's open.